Something as small as a single quantum bit appears to be influenced by forces from somewhere else. Astonishingly, the same molecule is found to be behaving the same way across the world, in London, as if the changes made in one place are instantaneously reflected in another. No, this isn't the plot of a science fiction thriller, it's the stunning discovery made by physicists working with the latest in quantum computing technology. This breakthrough has left researchers reeling, and it may just be the first real evidence that parallel universes, long only speculated about by physicists, are not only possible, they may be real, and, more shockingly, they might already be interacting with our own. For decades, the concept of parallel universes has remained on the fringes of science, largely theoretical and steeped in the strange mathematics of quantum mechanics. However, recent developments in quantum computing have opened a new door, offering a glimpse into something far more extraordinary than anyone had previously imagined. The quantum puzzle: can computers unlock the multiverse? At the heart of this mystery lies quantum computing, a technology that harnesses the strange principles of quantum mechanics. Quantum mechanics, the theory that governs the subatomic world, has always hinted at the possibility of parallel universes. The many worlds interpretation, one of the most intriguing aspects of quantum mechanics, suggests that every quantum event creates a split in reality, spawning multiple alternate timelines. Essentially, every time a particle is measured or interacts in any way, it could trigger a branching off into another reality, creating new versions of the universe. This means, in theory, there could be alternate versions of you living entirely different lives in parallel realities, one where you made a different decision, took a different path, or perhaps never even existed at all. While this sounds like pure science fiction, it's grounded in real mathematics, and now, quantum computers, machines that operate using the bizarre rules of quantum mechanics, may be the key to unlocking these parallel worlds and proving their existence. But how exactly do quantum computers relate to parallel universes, and why is this recent experiment so important? The strangeness of quantum mechanics. To fully appreciate the magnitude of this discovery, we first need to explore a few key principles in quantum mechanics. These principles are not just weird, they're mind-bending. 1. Superposition. In the quantum realm, particles don't exist in a single, definite state until they are measured. 1. Instead, they exist in multiple possible states simultaneously, a phenomenon known as superposition. For example, a quantum bit, or qubit, in a quantum computer can be both 0 and 1 at the same time, vastly increasing the computational power of these machines. 1. Quantum tunneling. This is one of the most bizarre phenomena in quantum mechanics. 1. It allows particles to pass through barriers they would normally be unable to cross, almost as though they vanish and reappear somewhere else entirely. This hints at the possibility that reality itself may not be as solid and fixed as we perceive it to be. 1. Quantum entanglement. Perhaps the most famous of all quantum phenomena, entanglement occurs when two particles become intertwined in such a way that the state of one particle instantaneously influences the state of the other, even if they are light years apart. This spooky action at a distance, as Albert Einstein called it, suggests that information can travel faster than the speed of light, raising the intriguing possibility that quantum information could even cross between parallel realities. The anomaly, a glitch, or something more. Now, let's return to the quantum experiment that sparked all this excitement. Researchers at leading institutions like CERN and Google's Quantum AI Lab were conducting routine tests on quantum gate interactions, something they had done countless times before. But this time, they noticed something unexpected, an anomaly. Quantum states, which were supposed to follow predictable patterns, began fluctuating in a way that defied known physics. Initially, the team thought it might be a glitch, perhaps a hardware malfunction or interference from external noise. But after isolating all variables and running numerous tests, they realized something startling: the anomaly wasn't random. It followed a distinct pattern, one that suggested the influence of something beyond the known universe. Some researchers believe that this fluctuation could be evidence of quantum interference from another universe, a brief and subtle interaction between dimensions. If this is true, it would be the first concrete evidence of parallel universes interacting with our own. This discovery is so extraordinary because it challenges everything we thought we knew about physics. It suggests that the universe we experience may not be as separate and isolated as we've always believed. In fact, it might be deeply connected to, and even influenced by, other, parallel versions of reality. The implications: could parallel universes be real? If this anomaly is indeed caused by an interaction between dimensions, the implications are mind-blowing. For one, it means that parallel universes are not just a speculative idea or an abstract concept, they could be real, and more importantly, they may be constantly influencing our own reality, often in ways we can't perceive. Could quantum computers be the key to understanding how these universes overlap and interact? If so, this discovery could unlock entirely new fields of research, from mapping the interactions between parallel worlds to discovering new forms of energy or information transfer that cross the boundaries of reality itself. But that's not all. If quantum systems can detect and react to disturbances from alternate realities, it raises the question: could we one day control this process? Could quantum computing allow us not just to observe these parallel worlds but to interact with them, perhaps even manipulate them in ways that could change the fabric of our own reality? The Mandela Effect, a link to parallel worlds. Now, you might be wondering, could this discovery also explain some of the strange phenomena we experience in our own world? One example is the Mandela Effect, a phenomenon where large groups of people share false memories about certain events. For instance, some people swear that the famous children's book character Berenstain Bears used to be spelled Berenstain Bears. Others insist that Nelson Mandela died in prison during the 1980s, even though history records that he was released in 1990. Could these strange discrepancies in collective memory be the result of subtle shifts between parallel universes, where certain details of our shared reality are slightly different from one world to another? If quantum interference is happening between dimensions, it's possible that our minds are, in rare moments, picking up on these shifts, causing us to remember things differently than we should. The predictions of Brian Cox, a step closer to reality. Some of the most respected physicists have long speculated that quantum mechanics might one day reveal the existence of parallel universes, and one of the most vocal proponents of this idea is Brian Cox, a leading expert in quantum mechanics. Cox has consistently argued that if parallel worlds exist, quantum computers might one day be the tool to detect them. His work has suggested that phenomena like entanglement and superposition could provide a window into these alternate realities. Now, with this recent experiment, Cox's predictions may be closer to becoming reality than ever before. If quantum computers are detecting anomalies that suggest interactions with parallel universes, it could mean that our understanding of reality itself is about to change forever. What comes next? So, what happens next? The data is still being analyzed, and researchers are cautiously running additional tests to confirm whether this anomaly is repeatable. If it is, it will mark a monumental shift in the way we view the universe, and our place within it. Could quantum computers become powerful enough to deliberately detect and manipulate the fabric of reality? Could we one day control our interactions with parallel universes, perhaps even shifting between worlds in a controlled way? While these ideas may sound like science fiction, they are now on the table for serious scientific inquiry. As quantum computing continues to evolve, we may soon be on the verge of unlocking the greatest mysteries of the multiverse. Conclusion: a new era in physics. What started as a routine quantum experiment has now opened up an entirely new realm of possibility, one where parallel universes might not only exist but could be directly interacting with our own. If this anomaly is just the beginning, then quantum computing might soon give us the tools to explore the hidden dimensions of reality in ways we never thought possible. As we continue to study this discovery and unravel the deeper mysteries of the quantum realm, one thing is certain: we are at the cusp of a new era in physics, one where the boundaries of reality may not be as fixed as we once believed. And who knows?